Okay, now without any further ado, now is the time to start the first session of our Blockchain Beginner series, The Foundation of Blockchain. And the speaker is none other than Keerthana Ramalingam. She's the Senior Blockchain Engineer of Blockbrew Engineering. So Keerthana started her career with Tata Consultancy Services India, where she got the opportunity to learn and develop blockchain-based applications. So initially, she started working on Hyperledger, which is a permissioned blockchain to securely digitize the data. And later, she moved on to public blockchain platforms like Ethereum, Polygon, etc. She has developed multiple decentralized applications on various blockchain platforms. She's currently working on a DeFi-based lending and borrowing application wherein the processes and terms are governed by the smart contract system. So Keerthana, we are looking forward to your session. Thank you so much for your time. Over to you, Keerthana.
Thank you, Anjali. Thank you for this lovely introduction. So let me present my screen.
Sure, thank you so much. And also to note that Keerthana just got recovered from COVID and she's in a weaker state, but still she's so strong to join today's call. Thank you so much for that, Keerthana. Really appreciate your enthusiasm.
Thank you. Thank you. Okay, Anjali, my screen is visible, right?
Yes, it is.
Yeah. Okay. Okay. Hi everyone. I'm Keerthana Ramalingam. I'm a senior blockchain developer in Blockbrew Engineering. I'm very glad that today I'm here and I'm doing this, doing this presentation, doing this session. Okay, so the projects which I'm currently working on are EasyFi and Trace Network. So EasyFi is an decentralized lending and borrowing platform, which is leveraging layer 2 solutions such as Polygon to achieve scalability and for low transaction cost. And Trace is an NFT marketplace where unique brand products are being made into NFT and being auctioned. So a little bit more about me. I did my bachelor degree in civil engineering, and then I got into TCS where I was being trained for Java early in training period, and then I suddenly moved into blockchain where I was working in a research and development team. The project which I'm working on was under a platform called Hyperledger Fabric. It is actually a consortium-based permissioned blockchain. So it is we were developing a POCs during those times that was for government organization. And then I moved into Ostrich Technologies. It is a medium-based, service-based company where I was leading a team of 8 engineers, and I was handling client interaction and project management. And I was in the role of lead blockchain developer, where I used to design, develop, and optimize and validate smart contracts on various public-based blockchains, which includes Ethereum, BSC, Polygon, and Tron. I also have experience in pulling on-chain Oracle price feeds and interaction libraries to interact with smart contracts. And I also closely work with current market trends, and playing around DeFi contracts would be, time filling for me. So today's topic is foundation of blockchain. So the topics we would be covering here today is like what is DLT and the types of DLT and the problems which is being addressed by the DLT, and obviously blockchain and blockchain protocol, and what is cryptocurrency and features, growth, and types of blockchain. So let's get jumped in. So the reason, because directly not jumping into blockchain and coming to DLT is like DLT. I mean, this DLT is standing for distributed ledger technology. So it is like managing a decentralized digital database. So that is what the blockchain is making use of. So understanding the DLT before getting into blockchain is it'll ease your path into blockchain. So coming to DLT, this protocol enables a very secure functionalities of the decentralized digital database. So this network eliminates the need of a central authority to keep a check against the manipulation. So it's like all the informations which is being stored or which is being given to the DLT will be stored in a very secure and accurate manner. Okay, so this is being achieved in DLT by help of cryptography. So if you take cryptography, it is all about keys and cryptographic signatures. So once the information is being stored into the DLT, it will become an immutable database, and it is being governed by the rules of the network, not under the rules of any central authority. So it's like, only the people's and people who are participating in the network can control the, can define the rules. So this DLT has a very great potential in improving the way government institutions and corporations works. So in terms of government, it can help with the tax regulations and issuance of passports, recording land registries, license, and then it can also outlay the social security benefits as well as the voting process which we have in current time. Also, this technology is making a way in industries, not only for the government and institutions, it is also for financial projects and music and entertainment industry. And when you take like supply chain management for managing diamond and any other precious assets, so that can be come under permission based DLT platforms. So once the file or data is being pushed to DLT, so all the files will be timestamped and then it will be given a unique cryptographic signature. So I'll tell you what is the cryptography and how the cryptography signature is being formed when you give a data to blockchain in the coming slides. So I mean, you have to understand this distributed database is like it will provide all the participants in this distributed ledger can provide an opportunity. I mean, not opportunity. It's like all the people or all the nodes which has been coming into the network can view all the data. So it is like verifiable, and then it will be auditable history across the network. So and then let's move to types of DLT. So DLT itself has permissioned and the permissionless variants, but the different types of distributed ledger that you can find presently in the market includes blockchain itself. So not only blockchain, along with blockchain, we have Hashgraph, we have DAG, we have a holochain, we have Tempo. So getting into the closer picture of all the things, first comes the blockchain. Blockchain, the transaction records are stored in a ledger in the forms of chains of blocks, that is a list of records. So this digital information stored in the block are time, date, and the transaction data. So based on all these data, the block hash will be created and the list of blocks will be growing from that. And the next is hash graph. So hash graph allows the storage of multiple transactions on a ledger with the same timestamp. So this records on the ledger on the hash graph is called event. Okay. So in the system, hash graph ensures there is no node to the network can change the transactions or any information. I think this is common across all the DLT. Next is DAG. So DAG is directed acyclic graph. So this is actually an improved DLT versions which has a very different structure. So DAG is also capable of supporting nano transactions. So since it is supporting nano transactions, it provides good improvement in terms of scalability with providing an expansion of the network. Next is Tempo. So Tempo is a relatively new addition that provides benefits of timestamping along with the DLT functionalities. So the main major highlights of Tempo is like because the need of creating decentralized application is growing, so they are providing way where there won't be any modifications when you use Tempo for public and private modules. So if you take blockchain, if you wanted to do a public based blockchains, and then you have to go for a public based platform to deploy on. So this is like a different this is like a highlight of Tempo, how they are handling the projects in a different sectors. So actually, what is the problem this DLT is solving? So if you take the finance today, which is being transformed by mobile technology, big data, cloud computing, artificial intelligence, and machine learning, right? So the advance and the spread of this digital technologies could dramatically increase financial inclusion by expanding access to financial services. So especially for underserved populations and among micro and small and medium enterprises, and also in rural and agricultural areas. So the potential of benefits of this transformation are very huge, but also the risk must also could be managed. So this is where this DLT comes in to solve several problems, which includes external barriers such as problems with contracts, financing, lack of trust, lack of information, and domestic and international market limitations, and IP rights, and governmental regulations such as bureaucracy. So what this DLT trying to do is like, since there is no any central authority to be handled the rules of the network, the contracts which can be made directly between the two parties. So if there is any two parties involving, there won't be any third party, or there won't be any brokers to be handling the payment structure. So when the asset has to be transferred from party A to party B, it can be directly transferred, and then all the data will be managed in the decentralized database. So next, blockchain. So blockchain is a shared distributed ledger that facilitates the process of recording transactions and tracking assets in a supply chain network. So there are only 4 characteristics you have to understand before getting into blockchain. One is decentralization and transparency and immutability and automation. So these are all the 4 main characteristics of blockchain. So if you look at this illustration here, this is actually a life cycle of a transactions you can take. So when the transaction is being requested or being initiated by the user, so this will be broadcasted to the network, and then from the network the nodes will be picking up the transactions. If I say nodes, the miners will be picking up the transactions, and then they will validate the transactions. So for validating a transactions, miners will get reward from the network. And then after validating a transactions, that block will be added to the blockchain, and then the global state will be maintained from there. So this is like a complete how the transaction is being initiated and how the transaction is being completed. Next is blockchain is not just cryptocurrency. So the reason I told, I mentioned here, like most people think like cryptocurrency, blockchain comes after cryptocurrencies. No. So blockchain's underlying technology is what making the cryptocurrency possible. So blockchain will disrupt many aspects of life, and the currency was the first one to hit. And there are several, various aspects of projects which are being developed and are being developed in the blockchain technology. So the sectors which is being given here are few of the places where this blockchain has been implemented. So these are all few statistics of blockchain. So the global blockchain market is expected to reach 400 billion in 2028, and there are other few statistics of blockchain. Okay, there are over 100 blockchain platforms existing today. So, considering the adoption of blockchain in various industries, blockchain will have a rapid growth in terms of project which is being built and the revenue which is being generated by implementing the decentralized applications on top of the blockchain. So not only cryptocurrency part, the number of projects which is being deployed are also rapidly increasing. So based on the specific use cases, the custom platforms are being built. So if you wanted, some of them are customly built for specific use cases, some of them are customly built for generic use cases, some of them are for enterprise use cases. So for example, if you take Bitcoin is only for medium of exchanges, medium of currency exchanges. So Ethereum came after Bitcoin, which also supports a user can deploy decentralized applications on top of this platform. So Hyperledger came after that, where Ethereum is completely a public based blockchain, where Hyperledger is a permission based blockchain. And then three use cases, and based upon the use case to bring up in the market, we can choose the platform accordingly. Types of blockchain. So before jumping into development or implementing blockchain, so we have to understand what are the types of blockchain which is being available and what are the projects which are being that can be implemented in the right platforms. So first is public blockchain. So public blockchain is completely permissionless in nature. So anyone can join, and it is completely decentralized. So public blockchain allows all the node across the world can participate, and then they can have equal rights to access the blockchain. So they can access the blockchain, and then they can create a new blocks, and then they can validate the blocks. So it is open to all the nodes. So the verification of these transactions are done via the consensus mechanisms, which are such as proof of work and proof of stake. Next is private blockchain. So private, if you say private blockchain, it has a central authority where it will be giving access to the nodes who can join into the network. So only the nodes which is being given access can join the network. So it can more of a partially decentralized we can mean. But for a specific use cases like business to business applications can be implemented in private blockchains, where the data has to be kept secure. Next is consortium blockchain. Consortium blockchain are permission blockchains. So that is governed by a group of organization rather than a single entity, like how the private blockchain is doing. So this consortium blockchain enjoys more level of decentralizations than private blockchains. So considering the level of security they have. So, however, the setting up this permission blockchain will be little more tougher than the private and public blockchain. So, considering the logistical changes as well as the potential anti-stress risk which is going to be taking into permission risk. So again, as I told you earlier, the Hyperledger is one of the major platforms where it is supporting a permission-based blockchain platforms. So if you want an example of a platform, example of projects which can be implemented in permission-based blockchains or a supply chain management system. So supply chain is a leading project which is being implemented in a permission-based blockchain platforms. Next, cryptocurrency. So cryptocurrency is just a medium of exchange, but it is digital, encrypted, and decentralized. So unlike the US dollar or euro, there is no central authority that manages or maintain the value of cryptocurrency. So instead, these tasks like managing and maintaining the value of cryptocurrency are broadly distributed among the cryptocurrency users itself. So the users, based on the trading values the user is giving up, the value of the cryptocurrency is being determined. So you can also use crypto to buy regular goods and services. Almost, now people are investing more into crypto than stocks and other precious metals. So unlike, while cryptocurrency is very novel and existing, exciting asset class, one should, before purchasing it, one should know how the cryptocurrency, what is the technology under cryptocurrency and how the keys has to be maintained safe, because there are a lot of hype which is going on in investing and buying cryptocurrency. So people are just jumping into buying it without knowing how to secure the private keys. So leading to that, people are losing their funds by exposing the when compromising the private key. So if you are going to invest in cryptocurrency, or if you're going to start with the cryptocurrency, you have to understand the technology behind it, because not like banks will have all the controls of your funds. No. So here in cryptocurrency, you are responsible for your funds. So no matter what, if your private key is being lost, then you can take that your funds is being lost. So you can take that the funds is already lost. So the private key has to be kept very, very secure. Next graph. So see, okay, this is like you can see Bitcoin from 2013 to 2017, the dominance was completely Bitcoin. After 2017, its dominance has been reduced, and other platforms like Ethereum, Solana, BSC are gaining market shares and developer adaptation. So because everybody wants to implement the projects, implement the decentralized applications on top of bringing up to the blockchain. So they wanted to be you have to have a platform where they can implement deploy a decentralized application. So this is how the Ethereum, Solana, and BSC are coming into picture. So obviously we have to talk about Bitcoin. So Bitcoin was the first cryptocurrency which is being printed by Satoshi Nakamoto. It's a decentralized digital currency. It enables peer-to-peer transactions, and it has been this peer-to-peer transaction is being maintained by cryptography. And the one of the main aspects of blockchain is preventing double spending, that has been addressed here. And currently, Bitcoin alone has a market capitalization of around 1 billion. And if you take other cryptocurrencies, the capitalization will be much bigger. So these are all some of the statistics of Bitcoin. So the average block size of Bitcoin is 1 MB, and these much transactions are being, average of this much transactions are being mined per day. and this is the mempool size. So if you ask me what is mempool is like if you create a transaction, the transaction is not suddenly will be going to the miner and then it will be get mined. So it will be collected in the mempool. So from the mempool, miners will be picking up the transactions and then they will be validating the transactions. So this is like size of the mempool, which is in Bitcoin. So this other more one more statistics. As you can see, there is total volume of Bitcoin traded across exchanges. Okay, the value has been steady, relatively actually minimum for the first 6 years, and it has steadily increased. And then today, the daily average trading volume is closely up to 400 million. Next, we'll cover up the key elements of blockchain. So I think this is after this key elements and features of blockchain, I'll give you guys a demo of how the blockchain works, which is done by Anders Bronsworth. Now let's finish this understanding. So the topics under this key elements will be peer-to-peer network, distributed database, public key cryptography, and consensus algorithm. So peer-to-peer network. So what happens in peer-to-peer network is like, so there won't be any central server or there won't be any central authority who will be handling all the data. So if peer one is requesting a data, then it has to request it to the server, and then it has to get the data from one more peer, and then it has to be sent to the respective peer. It's not like that. So if you wanted to send some send some fund from peer A to peer B, it has to go to the server, and then it has to go to the peer B. So if you take peer to peer, it is like if you wanted to directly send funds from peer A to B, you just have to send directly. There is no any central authority, because all the funds will be handled by your your keys. So you are responsible for your funds. So this peer-to-peer communication is done without any central administration or server, which means all the nodes will have a equal power and they perform the same task. So today, this P2P network are the foundation of most of the cryptocurrencies, and then this is making up the very significant portion of the blockchain industry. So in such network, without central authority, that could be a malicious actor. And then in such scenarios, the ability of the network to detect the fault and to detect the fault detection or tolerance will be the very critical across all the networks. So we say a peer-to-peer network is a location diagnostic because there will be no central authority to provide you restrictions that only this area this region users can be participating. No, there is no such limitations. So anybody across the node, whoever has the internet, can come and participate here. Next is distributed database. So distributed database is all about it not only, the blockchain will not only allow to add new data into the database, but it also ensures that all the users on the network have exactly the same data. So it will maintain a very global truth across all the peers on the network. So that's this blockchain is a distributed and decentralized linked data structure. So in distributed database, there is only one global state maintained across all participating of the peers, and the state is consistent, deterministic, and it is being replicated across all the nodes. So as like you have seen in this picture, all the database which is there will be replicated, will be given to all the peers. Next is public key cryptography. So this is like a very major thing. So when you take public key cryptography or asymmetric cryptography, it is a cryptographic mechanism that uses pair of keys. So each pair will have a public key and a private key. So public key has to be kept secure only with you, and then private key has to be kept secure with you, and then public key can be shared across the network or to whoever people you wanted. So the generation of this such key pairs depend on the cryptographic algorithm. So whatever the cryptographic algorithm you are choosing for the platform, so that the keys will be deterministic on that. So most commonly used algorithms are SHA-256. And so this encryption and decryptions, which allows two communicating parties to secure the data that is being sent to each other. So the sender will be encrypting the data before sending it, and then the receiver will be decrypting the data after receiving it. So while in transact, the encrypted data is being not understood by any intruder parties. So if you take the illustration here, Alice is the sender and Bob is the receiver. So Alice is trying to send some message to Bob. So he's signing it with his private key with help of Bob's public key. Okay, so whoever holds the public key corresponding to the encrypted public key will be able to verify the verify the message. So I'll tell you again. So Alice is the sender and Bob is the receiver. So Alice will have public and private key and Bob will have public and private key. So Alice is trying to send hello Bob to Bob. So imagine this, Alice will have the public key of the Bob. So Alice will be signing this message with help of his private key along with the Bob's public key. Okay, only public key of the Bob will be known because he cannot share his private key. So after this, after he broadcasts this transaction, transaction to the blockchain, so only with the private key corresponding to the public key in which it is being encrypted can verify the verify the message. So if a party if a person Ruby is coming in and then if he tries to verify this transaction, he cannot verify it because the corresponding private key of the Bob's public key is not with the Ruby. So only Bob has, so only Bob can verify this transaction. So this is how the public key cryptography will be working in. So this is where the signing mechanism, this is where the signing mechanism coming in, and then this is this after signing in, you will be getting a digital signature. Next is consensus algorithm. So this is also a very major part in blockchain. So a network can be set secure and decentralized when the network is able to achieve a common agreement. So everybody has to agree with a common agreement. Then only the network can be kept secure and then decentralized. So this is being achieved by this algorithm. So this algorithm allows a distributed system to stay together and to stay secure to maintain a single global truth of the network. So this also designed to achieve the reliability of the network. So the commonly used algorithm is proof of work that has been used in Bitcoin and Ethereum. So Ethereum 2.0 is expected to release with proof of stake. Let's have a very broad understanding of what is proof of work and proof of stake. So proof of work is like the miners who are trying to mine the blocks, they will be competing with each other with the power of energy they hold. So it's like higher the power, higher the work they can do. Higher the work they can do, greater the chance of mining the block is greater the chance of mining the block will be increased. So since he can able to mine more blocks, he will be earning more rewards. So if you take proof of stake, proof of stake is completely dependent on how much ether validator is going to stake. So based on the amount of ether the person or the node is staking, the percentage of validating the transactions will be given to the validator. And features of blockchain. Since we have covered the distributed and decentralized, we'll talk about immutability and smart contract. So we say this blockchain is immutable, right? So how exactly the blockchain is being can remain immutable? Okay. So one of the key elements that makes the blockchain immutable is the cryptographic hashes. So this is why the blockchain is immutable. So the main advantages of this hash is that it cannot be reverse engineered. So each transactions that is being verified by the blockchain network is being timestamped and then will be embedded into the block of information. And that information will be cryptographically secured by the hashing algorithm. So cryptography, in addition to the hashing algorithm, which brings the immutability to the blockchain. So if you take a structure here, see this is block 1, this is block 2, and nonce is a number which is being founded by the founded by the miners after validating the transaction. So this is the transaction data and then previous hash. So take this as the genesis block. So genesis block is the starting block of all the chain. So it will be the first block. Okay, genesis block is the first block. So there won't be any previous blocks before the genesis block, so that the previous hash of the block is 0. Okay, and then this hash is the hash of the block 1. So if you take block 2, so the block 2 will have the hash of the block 1. So this is how the chain of the blocks will be formed. So, and then if you try to do any malfunctions in block 1, then block 2 will also get invalid. Okay, we'll talk about that in the demo section clearly. Smart contract. So smart contract is simply a program on a blockchain that can run on predeterministic conditions. Okay, so if you write a smart contract with a definite condition and it is being deployed, the contract will completely work on whatever the condition which has been already written. So you cannot change, or you cannot do any modifications to the contract. So they typically are being used to automate the execution of a agreement, so that all the participants can be immediately certain of the outcome, and then without any intermediate parties in involvement, and then the time loss. So they can also automate the workflow, triggering the next auctions and where the condition is being met. So there are like 4 main features of smart contracts. One is speed, efficiency, and accuracy. Since only when the condition is met, the contract will be immediately executed. So it maintains the speed, accuracy, and efficiency. Next is trust and transparency. So since there is no third party involved, the complete trust will be on the smart contract. So everybody can see how the contract is being returned, and then they can evaluate the transaction. And then security. So as long as blockchain is kept secure, the smart contract cannot be hacked. And then savings. So I say savings because because there is no intermediaries to handle the transactions, it saves the associated time with the intermediaries. The time delays will be compromised. And then the fees which is being given to the third parties also will be reduced. This will be the last slide, I guess. So growth of the blockchain. So as I already told you, the global blockchain market size is expected to reach around 400 billion by 2028. The blockchain is seeing very steady adoption in small and medium enterprises, and also in big enterprises. So this illustrations shows the year-on-year spending of organizations in blockchain solutions across various regions. So this has been rapidly growing in this year, and it is expected to grow in the coming years. So let me just jump into the demo of how the blockchain works. Okay, so I hope everybody can see my screen. So this demo is actually created by Anders Bronsworth. So this he has also had a clear explanations of this video has been clearly explained, and it is being put it on the YouTube. You can, if you want, you can also share, you can also go and view, and I can also share you the link of this one. So whoever is starting with the blockchain, which is very new to the blockchain, please start with this. So this will give you a very clear understanding of how the hashing and how the blocks is full complete the background of blockchain will be understood. So the hashing algorithm for this example which we took is SHA-256 hash. So the field down here, this is the hash. So hash is nothing but a very random numbers, okay, with the prefixed length. Okay, so this is the hash for empty data. So if I try to type anything, so you can see the hash is being changing. So whatever I type, the hash will be changing. Okay, so irrespective of whatever I type, if you note, if you have if you understand, the length of the hash is not changing. Only the hash is being changing, but the length is not changing. So even if you write a book of data here, the hash won't be changing. Okay, so if I type blockchain, so you can see the hash is starting with EF77. Okay, so if I add something extra, then the block will be changing. So if I remove it, and then if I type blockchain again, then you can see the same hash has been created. So given the same set of data, the same hash will be generated. Okay, so you can type a number of data which is you can do. So the same hash will, the corresponding hash will be generated, and you have to understand the length of the hash is not changing, only the hash is being updating. Okay, and also given the same set of data, the same hash will be formed. So this hashing feature is being implemented in the block section. So if you take a closer look of how the block is being formed, so same hashing field is here. So the data field in here has been splitted to three fields. One is block, nonce, and data. So block is a number, so it will be incrementing, and then nonce is also a number. We can talk about nonce in later session, but understand that nonce is what which will be found by the miners after while creating a. They have to find the correct hash with finding the nonce number. So here you can see hash is starting with 4 zeros. So I am saying that the hash which has been starting with 4 zeros are being verified and being mined. So for this demo application, this is being given a green color, which background has been green color, which says the block is being mined and being verified. So what I'm trying to do here is like I'm going to inject some other data into the block, into the existing block, already mined block. So what it shows, the hash is being changed, though the hash is not starting with 4 zeros, and then the background is also get to green red color. So which means that if you see the hash, it is not starting with 4 zeros, which means this block is not mined and this block is an invalid block. Okay, so I have to find the nonce. Okay, I have to find the nonce where I can get this 4 zeros at the in the hash. So I can try for in any numbers. So that is what the miners will do. So it will be starting from number 1 and then it will go on. So this 5848 is the place where the data is being mined and then the hash is being created. So this is how the block works. So if I add some data, then I have to mine it, and then I can get the hash, and the nonce will be changed respectively. Then now let's implement this block into a chain of blocks. Okay, so you can see like there are chains of blocks here, starting from block 1 to block 5. So this is block 1 and its corresponding nonce and data. This previous. So you can see this block is called Genesis block. As I already told you, Genesis block is the first block. So the previous hash will be the 0 because there will be no any previous blocks. So this is the hash of the first block. Okay, and then if you go to block 5, and this is the hash of the block 5, and if you see the previous hash of the block 5, it is the hash of the block 4. So AE8. So AE8. So this is the hash of block 4, and this previous hash is the hash of block 3, and then previous hash of block 3 will be hash of the block 2. So this is how blockchain is maintaining the chain of blocks. So everything will be chained together by the help of the previous hashes. So if I try to do something, add some data to the block number 5, this block number 5 will be a invalid block. So the malicious actor has to mine the block again. So to get the hash of the starting with 4 zeros. So if it is a last block, then it's fine. So what will happen if I try to impregnate something in the block 2? So for example, I'm typing something here. So what happens is like, since the blocks is being chained to, it is being chained with the preceding blocks from the blocks and so on. So all the blocks from the starting from the block 2 will be a invalid blocks. So see, the hash of the previous hash of the block 2 is changed. So since because of that, this has been changed, and because of this, block 4 is being changed, and this is because of block 4, 5 is also changed. So the malicious actor has to mine the block 2, and then the user has to mine the block 3 again, and then again 4, and then 5. So for this example, we have only 5. For example, take a scenario where there are millions of blocks which is been already mined. So if a user tries to change anything, and then for tracing for mining all the all the blocks from the block the user has been tried to manipulate, the user has to mine all the blocks. So that is completely impossible. That requires enormous amount of power to do that. So that is why the blockchain maintains the security since it is being linked together. So if it is a single chain, it is fine. So what if the user is, you can ask me like, what if the user can able to mine all the preceding blocks? So that is where we come to a distributed blockchain. So you can take this as a peer A. Peer A is a node number 1. Okay, peer B is node number 2, and peer C is node number 3. So as I already told you, all the peers will have the same set of data. Okay, So it is nothing like the peer 1 will have different data and peer 2 will have different data. So it is a one global truth. So all the peers will have the same set of data. So if you see here, if you see the block 4 is like AE8B and then E4B. So if you go here, same thing, AE8 and then E4B. If you go here, AE8 and then E4B. So when a malicious actor, so for example, let's take this peer A is going to be a malicious actor, and then he is trying to, implement something. He is trying to, rewrite the existing block. Okay, so in the block number 2, he is trying to add a, add some data to the block 2. So what he is trying to do is he is mining the block 2, and then he is finding the nonce, and then he is mining the block 3, and then the block 4. And then the block 5. Now all the blocks has been mined, but the problem is like the hash which the user has got in the block in the peer A is A to D and then F67. But the hash which is been already there in peer B and peer C are different. Okay, so since this user can claim that his block is the right block, and then this two peers can say this is the right block. So since the majority of the block says this is the right block, so not on in the existing platform there won't be only 3 peers. There will be like a number of nodes will be connected across the network. So since the majority of the people says this is a valid block, this malicious actor block will not be taken into consideration. So this chain of blocks will be considered as a global truth. Okay, so this is how the malicious actor is being, a malicious chain will be eliminated in the blockchain. And then this is all these illustrations are without the data. So let's just look at how the for example, when there is any transaction in a blockchain, how the transaction is being traced back, or how the transaction is being handled in the blockchain. Let's see that. So the same example, peer A, peer B, and peer C are there, and then there are list of transactions is being there on the data has been there on the blocks. So for example, Darcy is trying to send $25 from his account to Bingley, and then Elizabeth is trying to send 4.27 from his address to Jane. Okay, so these are all like list of tokens, or I mean it can be any assets. So that is being transferred in this blocks. So this is one transaction, this is one transaction, this is one transaction. So all the transactions which is being bundled, and then the block has been formed. So here all these transactions are bundled, and then the block has been formed. So based on this data, so this hash is being formed. So if I try to manipulate any data here, see, all the blocks will be become invalid, and then this will be the malicious chain, and then this too will be the global truth. So the same scenario, how the distributed blockchain works. So the reason here, the reason why we come here is like the miner who is trying to mine the block of, mine the first block, has to know whether Darcy has $25 to send from his address to Bingley. So this miner or this transaction has to be a valid transaction, right? So we have to know whether the Darcy has the respective balance or not. Okay, so for this understanding, this miner has to trace back the transactions, and then he has to find whether Darcy has the balance or not. That then only he can, he can say this transaction, this block is this transaction is valid, and then that transaction can be included in the blockchain. So that is where Coinbase transaction is coming in. So if you say what is Coinbase transaction, is like Coinbase transaction is the first transaction that is being generated in the block. Okay, so since it is the first block, it has the previous block as 0, and then it has a block hash. So what happens is like in the first transactions itself, in the first block itself, $100 worth of tokens is being transferred to the address. Okay, and then in the next block, what happens is like Andres is sending some amounts to other people, and then these other people are sending some amount to other next people, and then these next people are sending amount to other set of people. So if we come to this block number 5, if a miner is going to validate this transaction, validate this block, so he has to know whether Jackson has $2 worth of token to be sent from his address to Alexander address. So what the miner will do is he will trace back the transaction. Okay, since he has a previous hash, so he will go to the previous block to check whether the Jackson has the amount or not. Okay, so he will come here and then he will see this Jackson has been received $8 worth of token from Sophia. Okay, so then he has to know whether Sophia has balance or not. So what happens is like then he will trace back with the help of previous previous hash. Then here there is no trace of Sophia. Then he will go back again. So here if you see, Sophia has been received $10 from Anders. So how Anders got the balance? So Anders got the balance at the Coinbase transaction. So this is how the the state of blockchain and the state of state of balance will be verified and will be managed in the blockchain. So it will be like, since it is being chained together, there will be no point where the it will prevent the double spending, or no point where the user can spend something which is being which is not there in account, and and also he cannot do the double spending. So this is how the Coinbase transaction work. Also, in this Coinbase transaction, if you try to manipulate any data, then it will become an invalid block, and then these two will be the global, and then this chain will be the invalid chain. And I think, hope you all clear about this. I can share you the link in the chat. Yes, so I would like to take up the questions right now.
Hi, Keerthana. There are a few questions
Hello.
in the Q&A box.
Yes, yep. Okay. Let's go from again. If a blocks contain other data like healthcare data or governmental administration instead of financial, how will the miners validate them? So Divya Preeta Arvind. So if you, I mean, your question is like, what will if a block contains any other data like a healthcare data or government land registry data instead of a financial transaction, how the miners will validate them? So obviously the healthcare data and the government land registry data will be not under the public blockchain. Okay, so it will be under either a private blockchain or a permission based blockchain. So that will be completely under the central authority, which means like there will be any central authority will be allowing the node, and then will be allowing the node how to work the transaction. So that will be completely dependent on the central authority which is being governed. When the chain is long, is there any performance issues in Coinbase? No, because the chain is already long. There won't be any such issues. Say we have blockchain-based accounting software, would you then not be able to correct the accounting error in blockchain unless you have remined the entire chain? In this case, it would then seem that the way to collect an accounting error would be a process correcting accounting entities as a brand new block. Okay, I think I didn't get it.
Hi, Keerthana. Sorry to interrupt. I think
Yes.
the others are unable to see the questions. So maybe I'll just post the questions in the normal chat as well, so that others can also view. Yeah.
Okay, please do.
Sure. So let me. So which question are you referring to right now?
Okay.
I think Divya Preeta's is answered. So let me just paste the question in the chat right now.
Yeah.
Okay. Which is the next question that you're referring to, Keerthana?
Last is Manigandan B. Does the peer B and C is replica of peer A? Is my understanding right? So every peer will have the same replica, Manigandan. And then I didn't understand Helena's question. Helena, if you want, you can please, refresh it. I didn't understand. And Rahul, who checks the global truth and how the hackers blocks becomes invalidated? Yeah, as I told you, global truth is like, which is being spread across all the peers. Okay, and then when the malicious actor is trying to hack any blocks, then since the majority of the peers will have the same global truth, so that can be that can be pointed out. And then do we mine blocks to get the correct nonce number before the block joins a blockchain? Yes, absolutely. So you have to first validate the transaction before giving the transaction to the block. So that will be joined in the in the global state. And then if there is a private blockchain, what about decentralization? Yeah, as I told you, only business to business related use cases can be implemented in a private blockchain. Yes, I agree that is less decentralized. If blockchain cannot maintain decentralization, then what is the point of using blockchain? So yeah, this is for a specific generic use cases. So if you take a government organization or healthcare organizations, so they obviously have to maintain a separate permission based ledger. Are there reward tokens like Ether, Bitcoin generated in all other types of blockchains DLT? Okay, so see, Ethereum has a native token as Ether, and Binance Smart Chain has a native token as a BSC. But if you take Hyperledger, that doesn't have any cryptocurrency as a native. So in that, there won't be such rewards. So it's based on the platforms which you are choosing in Deepak. When decentralization comes into picture, agents of centralization. Okay, when decentralization comes into picture, the agents of centralizations, such as banks and other third party, are trying to make it centralized again. No, not such case. There are a lot of banks which are already exploring on how the R3 Coda works. So as I already told you, there is an R3 Coda platform which is only for financial purposes. I think there are few minimum banks which they have already introduced R3 Coda in their in their banking structure. With quorum, they say mining can be done first. So can a hacker so the quorum is completely a private blockchain. So the mining will be depend on how the network is being formed. Okay. Can one type of blockchain interact with another to exchange encrypted data? So not the encrypted data. So for example, if you have currencies in Ethereum, and if you wanted to get that, if you wanted to bridge that Ether or any other currencies from the Ethereum to Binance Smart Chain or Polygon, there are a lot of bridges which has been available. So where you can transfer the assets from one blockchain platform to other blockchain platform. Deepak. I think I covered. Okay, in general, what and all domain can use blockchain apart from finance sector, and how it is being useful? Okay, see, if you take finance sector, only cryptocurrencies plays into role. There are a lot of other platforms where people are creating decentralized applications. It can be gaming applications, it can be supply chain management, or it can be handling the data. It can be anything. Can you give examples of use cases for other types of DLT? Yeah, please go ahead and have this platform names I can give you. Go and explore on DAG and then Hologram and Tempo. So I think DAG will, question this and answer this question. Okay, okay, if you want to become a validator in proof of stake, where we need to stake a amount, how much minimum staked amount in Ethereum. So I don't know what is a minimum staked amount, but there are various passive income platforms also is there, where you can invest your if you doesn't want to be a validator, you can just invest and then you can also income. So if you want to be a validator, you can go stake in the chosen platform, but the platform which you are, because there are a lot of other platforms where they are using proof of stake, but the platforms which you are going to be choose should be very legitimate, because you don't want to end up losing the funds. Okay, Anjali, I think that is it.
Sure. Thank you so much, Keerthana. So if any of you have any questions, please join the Slack channel. Keerthana is also available there, and we'll be able to help you and answer some of your questions. And thanks to all the attendees also for joining, and special thanks to Keerthana. She was not keeping well, still she took this session. Thank you so much, Keerthana, for your efforts. And we will have our next Blockchain Beginner Series Session 2 next week, same time. So see you all then. Thank you all, and please take care of yourselves. Stay safe.